for today is probability distribution. This is a very important topic, and the first term to be understood here is called random variable. Random variable. What is a random variable? Understand this try to understand this properly. Let there be a real variable x. Why I am using x? Because this is the standard notation. So you can use any letter, but in most of the books you will find the real variable is expressed as x, capital X. So if x be a real variable associated with the outcome of a random experiment. What is a random experiment? You know very well, you must have studied this in probability. So if we have a random experiment, the output of which is this x. If this x is associated with that, for example, let me explain it with an example. If we throw a die, we get 1, 2, 3, 4, 5 or 6. This is the outcome, or these are the outcomes of throwing a die. Let x be associated with one of the outcome or any of the outcome. Let x be the outcome of getting a 3. Okay, so what is x? It is the outcome of getting a 3. Now this is a real variable, but is it necessary that when you throw a die you get x? No. For example, let us put x1, that is the outcome of getting 1, x2, outcome of getting 2. This is a real variable, undoubtedly, but is it necessary that when you throw a die, you get x1 or x2? No. Why? Because it is associated with the outcome of a random experiment. Since it depends on chance, therefore this real variable is called random variable. Clear? Since this real variable x depends on outcome of a random experiment. Clear? Therefore it is a chance, it is a matter of chance. It is a matter of chance that you get x. Therefore, this real variable becomes random variable. Clear? So this is the meaning of random variable. How a real variable becomes a random variable? Now, this must be clear to you. Now, this random variable is also called stochastic variable. These are some terms which are used in different books. In some book you will see random variable, in some book you will see written as stochastic variable, or mostly you will see variate. This term variate means random variable, so don't be confused. Now the second thing is, how we denote it. We denote it like this: P of x. This is the standard notation. Similarly, how we denote P probability, and when we write P x equal to A, it means probability of this random variable x at A. Clear? Or this can be like this also: probability of random variable x greater than or equal to some value, let's say A, or probability of this random variable between A and B. So this is the way we denote random variables. Clear? Now, if the random variable takes finite number of values, that is, it is 1, 2, 3, 4, let's say up to 100, or it is 1.1, 1.2, 1.3 up to 1.9. So these are finite set of values. When this is the case, it is called discrete random variable. Discrete variate. variate is random variable. But if in a given interval, let's say from 1 to 2, it takes infinite number of values, that is uncountable number of values, that is, it is continuous in this. It may take 1.1 or it may take 1.2369. So it can take any value between an interval. So that is called continuous variate. Clear? What is continuous? When we call something as continuous, for example, let's take example. If we say the number of persons in a room, it can be 1, it can be 2, it can be 3, it cannot be 3.23. So this type of counting is discrete. But when I say, you say height, okay, the height of a person, it's not necessary that the height of the person can be 1 feet or 2 feet. It can be 2.32 feet. So height, weight, length, these are something that has a continuum, that is in continuum. It has, the value is in continuous form. You can have any value between any two intervals. So that is called continuous. So similarly, we have discrete variate and continuous variate. So this is very important to understand, because our study of probability distribution will be divided into discrete probability distribution and continuous probability distribution. Clear up till now? Now, we'll start with discrete probability distribution. What is discrete probability distribution? You are clear with what is discrete random variable? Based on that, we have discrete probability distribution. Let's see what. So, let the probability of x for xi, that is, the points are varying, random variable is, we have different random variables. For example, if we throw a die, we have x1, that is the outcome of getting 1, x2, outcome of getting 2. So that for throwing a die, it will be x1, x2, x3, x4, x5, x6. So probability of x equal to xi. Let us define it as pi, small pi. Okay. If this p of x at xi be pi, then the set of values of xi and pi, the set of values of xi and pi, this is called discrete probability distribution. Clear? The set of, if the probability of x, the random variable at xi is pi, then xi with pi, if we draw a table where we have xi and we have the associated pi, the probability, that is called discrete probability distribution. For example, the random experiment is throwing a die. So x1 will be the outcome of getting 1, similarly x2, x3, x4, x5 and x6, probability of getting 4, probability of getting 5, 6 and so on. What is the probability associated? You have studied in probability theory that this is 1 by 6. Getting any number on the die is 1 by 6. Then this is xi, this is pi. This is 1 by 6, 1 by 6, all are equal. So this distribution is called discrete probability distribution. We'll see examples to understand this. Clear? Now, few things are very clear if you look at this. First is, if you add all the probabilities, this will be 1. It has to be 1. The total number of probabilities cannot be greater than 1. Second is, this pi has to be greater than equal to 0. Clear? And this, let this be 2. Then 3 is, this pi, individual pi will be less than 1. Clear? Or at the most it can be 1. If there is only one deterministic value, it will be 1.